By 2030, over 70 billion devices will be connected. Imagine the next generation of IoT. This new IoT will integrate seamlessly, need little power, and be compatible with other systems. It will also be robust, reliable, and inexpensive. In 2022, this revolutionary IoT will be a reality, available for everyone, everywhere, and for all devices. Its origins: the Argos geopositioning and data collection satellite system, the first IoT system in the world. Building on this proven system will provide connectivity for a whole host of activities: extreme sports, agriculture, small-scale fishing, safety at sea, logistics, and many more. Kineis opens up a new world of possibilities. You've been waiting for this. Wait no longer. Sign up now for the first IoT connection from space.
Hello everyone, welcome to this new webinar. So we put a small video to wait for the last attendance, but so we're glad to welcome you here for this new webinar entitled Kineis and ST, an off-the-shelf evaluation board to start satellite communication. My name is Clément Tricot. I'm a field application engineer at Kineis, and I will present today. I will do a brief introduction to this webinar before letting the floor to Anissé Djemo from ST Microelectronics, who we are glad to welcome here. So you can see their cameras showing up.
Hello. Hello everyone.
And Steve Amard from Kineis, also, who will continue this webinar on the Kineis integration into the STM32WL chip. So let's start with a small introduction with the agenda of this webinar. Thank you, Steve. So let's start with the agenda of this webinar. I will do a brief introduction on the offer overview. Then Anissé Djemo will speak about the Nucleo STM32WL chip. And Steve will finish with the Kineis stack integrated into this chip. And then we will finish with questions and answer for if you have any questions. So I'll start with the offer overview. So at Kineis, for the past years, we've been offering a few discovery programs that you can see here. Some of you may be familiar with the Shuttle program, which is useful to discover Kineis with a full demonstration solution and a platform that we offer to visualize the data. So it allows to quickly deploy a proof of concept in real conditions. So for different use cases, for tracking applications, for instance, or light smart metering. And it's all included, so the finished device and the platform for 6 months. We also have the Space Priority Program, in which we provide evaluation boards and modules to directly test Kineis connectivity, one way with the KIM1 module, or two-way now with the KIM2 module. This Space Priority Program allows to send the first messages to Kineis satellites, thanks to the evaluation boards and user interfaces. So the user interface for the evaluation board and the user interface also to retrieve the data from our servers. And it also allows to build a small demonstrator by assembling our module evaluation board that come in a shield configuration with Arduino, for instance, Arduino boards. But now, with this webinar, we are presenting a new smart SAT program, which comes with the STM32WL chip that Anicet will present next, and which allows to access and use all the Kinesis software libraries on this existing transceiver chip. So we provide you with the precompiled library with a demonstration application code for to perform the first Hello World transmission. And Steve will enter into the details on this part. To quickly introduce the Kinesis radio driver stack, because Anicet and Steve will further enter into the details. So it's the advantages of the STM32WL chip is that it's a low-cost standard MCU plus a transceiver. It's both an MCU with a transceiver port, widely used in IoT applications and IoT devices. It's a very small form factor to integrate. It's a chip, and it allows device manufacturers to have a similar build of material as existing terrestrial devices that they might have, with an additional PA, power amplification stage for transmission to Kinesis satellites. But Steve will enter into the details. And it's a chip that is easy to integrate with the software libraries that we provide for especially the Kinesis modulation. And it's a pre-validated design for Kinesis certification. So I will leave the floor now to Steve Amar from Kinesis to enter into the detail, to Anicet Jaimo first, sorry, from ST Microelectronics, okay. To present the STM32WL chip.
Okay, so let me start. Here it is. Okay, well, so hello everyone. First of all, I would like to thank you all for joining this webinar. So I would like also to thank Kinesis for inviting ST and also for selecting the ST wireless microcontroller, the STM32WL, as a reference platform to run their wireless stack and to enable satellite connectivity on this product. That's really great. So my name is Anicet Jaimo. I am a product marketing manager responsible for sub-gigahertz microcontroller at ST. So the STM32WL is at the heart of many wireless applications. It provides the flexibility to support multiple protocols, the capability for long-range communication, and a low power consumption to achieve longer battery life. It has been already widely deployed on terrestrial network, like for LoRaWAN, Sigfox, wireless bus. And now, thanks to Kinesis, it is also possible to use the STM32WL for satellite communication. Satellite connectivity can answer the need of asset tracking market. So thanks to a global coverage that it provides, it can also be useful for agriculture application where there is low or no network coverage in some remote area, for example. And so now I would like to let you have a view on more detail on the STM32WL. And then after that, Steve will tell you more on how Kinesis use this MCU to enable the satellite connectivity. So what is this STM32WL? So the STM32WL is a system on chip. Why we call it a system on chip? Because it integrates several components inside. One low power microcontroller, the STM32L4, plus a multimodulation radio, and one Cortex M0 Plus core to provide better security. And all of these features comes in a single die that we call STM32WL, with the WL standing for wireless long range. So now I will show you what are the main benefits for the application and how this product can be applied for satellite connectivity. So let's see here the main reason why Kineis chose the STM32WL as a reference platform for satellite connectivity. First, the radio. The radio that is a multi-modulation radio. So Kineis succeed to implement their own modulation and to run their own protocol stack on the WL, on the WL core, the CPU core of the WL. Then second point, it's about the massive integration, because as we have seen, it is an all-in-one die solution. So all the radio, the application processor, even a dual core is coming into a single die. And that helps to reduce the form factor of an IoT device. And Kineis made a nice reference design with a small form factor that you will see later. The low power performance, because low power is quite important for IoT device, and it allows also to extend the battery life of an IoT device. And here we leverage from the STM32 low power process that provide low power mode with low leakage currents. And then the last but not least, it's about security, because we all want to protect our data when it's about sending it to the cloud. So the STM32WL provide an hardware isolation between the two cores of the product that allows to isolate the application from the protocol stack, for example. So these are the four main reasons to select the STM32WL. So one important point to take into account to design a sub-gigahertz application is the frequency regulation in your country. And here, to ensure a worldwide compatibility, the radio of the STM32WL provides a wide linear frequency from 150 to 960 megahertz. And that allows to support each country regulation. For example, 868 megahertz in Europe, 920 in the US, or 470 in China. And this wide frequency range has been really useful for Kineis, because they succeed to configure the product at the right frequency at 400 megahertz to connect to their satellite. And that means that with the same microcontroller, the end user is able to select the frequency to operate on both terrestrial or satellite connectivity network. One key requirement for satellite connectivity is about power output, because the wireless device needs enough power to transmit the RF signal and to reach the satellite in the space. And here the STM32WL integrates an internal PA that provides to Kineis enough power to reach their satellite. So that's really internal. And by using this one, it can reach the satellite. And there are actually two power amplifiers in the product. One low power PA that can be used for terrestrial network, for example, and this one can go up to 15 dBm. And one high power PA that can be used to enable long range connectivity, such as satellite, and that can go up to plus 22 dBm. So here again, this offers the capability to use the same product to target both satellite and terrestrial connectivity. So we have seen the benefit of the product features. And here you can see ST offers in terms of ecosystem. With on the left, you have the hardware tools that we provide. We have, so Clément was mentioning about the Nucleo board, the STM32 Nucleo, that can allow to make a quick prototype of an application. And this will be presented by Steve later, how they use the Nucleo board to implement their Kineis stack. With France Designs, we are providing a set of schematic layout. I will show you later how to get access to such reference designs, and modules from partners. And recently, last week actually, we have announced a new device, an IPD balloon that comes with the STM32WL. I will not spoil more than now. I will tell you more about that later. The tools on the PC, the development tools, and the software stack. So with the stack provided by ST, LoRaWAN stack, Sigfox, and we leverage from partners with Stackforce for wireless M-Bus and MyOT, and Zeta for ZFICent, and of course Kineis for the Kineis stack. Here, just to give you an overview of the portfolio of the STM32WL, with you can see the flash variant, different flash that you can select, 2 packages that are available, QFN package, easy to layout package on a 2-layer PCB, or a BGA package that can be used, that can reduce the form factor because it's a 5 by 5 millimeter package, and that can increase also the numbers of GPIO depending on the need of the application. If there is a need to have more control, more GPIO to control external devices. Well, here is the last update of the STM32WL. This is the IPD. So what is an IPD? Actually, when you use today an STM32WL in an application, you need several components and balloon between the MCU and the RF antenna. So that takes space, that adds complexity, and also that brings many performance variation across all the parameter, temperature, tolerances of the component. But now with this IPD, we integrate all of these components into a single device that we call IPD. And this helps to reduce the form factor. This helps to make the design much more simple. As you can see, just by 1.2 millimeter square, we can integrate all the components that are required here. So what is inside? Inside, we have the matching network, the balloon, and all the harmonic filters. And that's with a really small footprint, as you can see. Actually, we have a set of several IPD. You can see here, 9 IPDs in total, depending on the frequency that you want to operate. So here we talk mainly about terrestrial frequencies, as you can see, with the US band here, 920, the European band with 868, and the China band here with 400 megahertz. So also you have, depending on the PCB layer of the application and depending on the package of the STM32WL. If you want to get more data, more information, you can scan the QR code here and you can get more information on our website in this way. And the last things that I wanted to introduce you is also, if you want to start your application based on STM32WL, you can get access to many materials that ST is providing that include a set of schematics, a set of layout and bill of material. And then again, you can scan the QR code, you will get a set of all the reference designs, depending on what you need in terms of frequency regulation, depending on the layout, on the numbers of PCB layers that you want to use on your application. Okay, I'm done on my side. So I think I will leave the floor to Steve to show you the Nucleo board, the WL Nucleo board, and how it has been used to implement Kineis stack.
Okay, thanks, Anise. So I will take the presentation again. So what is the Kineis stack? So as Clément has said, we have two ways to transmit today with messages to the satellite. Using a specific module called a KIM module, or using evaluation kit like a Nucleo board. And this is the second way we will describe here. So this evaluation board is available on the shelf. It is not provided by Kineis. You can find it at any distribution system. You can buy it through Mouser, GGK, or ST directly. This evaluation board is a good candidate for Kineis, for Kineis, and also for all hybridation with LoRa, Sigfox, and other Zeta, and so on modulation. So let's have a global overview of this board. As mentioned by Anise, the output level, the RF output level used for Kineis is 22 dBm. It allows us to target some specific services for Kineis in uplink. The antenna which is provided with this evaluation board is quite not good enough, not efficient enough to be used for Kineis. So that's why we prefer to use a links antenna. You will see later, we will give you the link to use this antenna with the Nucleo board to transmit correctly to the satellite. Now, this board is has two different versions. One is GC1, one is GC2. GC1 is dedicated for terrestrial IoT, LoRa, Sigfox, and so on. The GC2 is more dedicated for 460 megahertz. And this is the good candidate for us because we are working at 400 megahertz. So without any modification, you can buy this board on the shelf and just put the Kineis stack inside, and you can play and transmit messages directly to the satellite. Now, the limited access we provide with this Nucleo board is due to the RF output level, which is limited to 22 dBm. So when you will intend to make your own design based on this RFIC, we will provide to you some reference design to increase a little bit this RF output level. Anyway, all the modulation we need to transmit some data to Kineis satellite are available now with this STM32WL chipset. So now let's have a look on what do you need in terms of hardware to start communication with Kineis. So you need the Nucleo board, GC2 board. You need the links antenna. Okay, so you replace the evaluation kit antenna provided by the links antenna. And if you intend to make your test locally in your lab, you can use also an equipment which is an SDR-based equipment coming from analog device. You need only these three hardware to start communication with Kineis. Now, okay. The software prerequisites are the STM32Cube programmer, the STM32Cube IDE. So tools are available on ST website. From Kineis, you need two kinds of firmware. One is used to get the activation code from the board, and the one will be the complete project you will receive from Kineis to build and to make your own application on this evaluation board. You need also some serial link terminal running on PC. Just to be able to communicate and control the evaluation board through a UART link. Now, the first step when you get your board is to use the STM32Cube programmer to flash a software which is provided on the Kineis knowledge base web application. You download this X file, you start the programming, and then push on the reset button on the board, and it should display through a terminal, which can be real-term, tera-term, hyper-terminal, and so on. And you could see on the, displayed on the UART a big number, which is the activation code. So with this activation code, you just send an email to the support team with this activation code, a photo of your Nucleo board, and a SmartSat agreement you can sign and send also in this email. And with these three parts, you send the email to the support, and then you will receive, generally in 1 day or less than 1 day often, you will receive a complete project, which is the KIM WL firmware package. This is a compressed file, okay? And you use the STM32Cube IDE to open as archive this project with the ST environment tool. And then you will have access to the application, to some drivers, the Kinesis stack, and also you will be able to run, to debug, and also to flash if you want this software. With this package is a generic package which do not contain the Kinesis credentials. This package, to personalize your Nucleo board with the IDs and keys and so on, all credentials to be used to communicate with the real satellite, you need a Kinesis data.c file you integrate in your project before compiling. Okay. Now, what can we do with this software? So the next step, I will introduce one of the two ways to play with this evaluation board. So you have built your project, and now you have something which is running and ready to send some frame direct to satellite, or also to the satellite emulator. So the satellite emulator, what is this? This satellite emulator, through a PC tool you can download from the Kinesis website, on the SDR equipment, you plug them together through USB link, and this is replacing the satellite, the base stations, and also a part of the service center when you can collect your data. So this is helpful to play with the Nucleo board locally on your in your lab, and it is using the real radio transmission, and this SDR-based equipment is able to demodulate locally the signal as it is done by the satellite. So now, if you want to play with the satellite emulator, you just plug the KDI. This KDI is an application, a PC application, which is using the UART link to communicate with the evaluation board through the UART link. You connect your Nucleo on the USB port, you start the KDI application, and this KDI application allows you to send some data to the Nucleo board and control it. On the other side, you can also run the satellite emulator application. You connect the Pluto SDR equipment on your PC. You launch the executable, and you choose the good modulation, which is used by the Nucleo board. And you can send the message with the KDI and receive it on the and display it directly to the on the satellite emulator application. So this is the first step to check if your device is working correctly. And then if you want to communicate directly to the satellite, through your support email activation, on Kineis side, we have created an account on our service center. This service center allows you to replace the satellite emulator by real satellite. So you use always a KDI application, but at this stage, you will transmit directly to the satellite. So the only thing you have to do on the KDI is to be sure that there is a satellite receiving your packet. So you choose the pre-pass connection on the KDI. You import a specific file which is containing all the satellite passes for this application. And then you use the KDI to send your payload and to get them back through the service center. Normally, you should have received an email to connect on this service center. So now you can play with the Nucleo board with the real satellite, play locally with your emulation. Now, the next step. During this evaluation, which has a duration for the SmartSat program of 3 months of connectivity, you would like to switch into your homemade on chip on board design based on the STM32WL. So for that, you need you have 2 solutions. You would like to make a very low power design, which is based on the Nucleo board reference design, but removing all the unused components. And we provide at Kineis a specific reference design containing the antenna, the ground plane, the STM32WL with the crystal, the TCXO, and so on. And we provide a specific application and specific driver to be adapted to your hardware. This kind of design allows you to have access with some specific satellite in a limited access today because we have only 1 satellite receiving at this low power transmission this reference design messages. So to benefit of the complete uplink offer provided by Kineis, it is better to make a design based on STM32WL, an external PA with a specific antenna, or you can do your homemade antenna. And through this design, you will have a complete access to the full constellation, existing constellation, and also the future constellation with all the uplink services provided by Kineis. So now let's have a look what can we do. This reference design is included in a specific program provided by Kineis, where we will give you all the support to integrate our reference design to support you during this integration and to support you to go into the certification step, which is the last step to allow you to build and to manufacture many devices and to be sure that the modulation or the RF quality of your device will be good enough for our satellites. We give you some reference design with the PA, some filtering for harmonics and so on. And through this kind of reference design, you will have all the access for the software and the hardware to build your own device and make it ready for the certification and then deployment. Now, in terms of software, what can we provide? We provide on the left we provide the existing stack, which is running on the Nucleo board. It integrates the modulation control through the STM32WL modulator. It is using the ST hardware abstraction layer drivers. And we provide two kinds of application in this software. One, it is to use the AT command-based control. And one, it is to, with a flag for compilation, you can implement your own customer application, providing a simple API to send the data over the Kinesis stack. On the right, you have a different stack which is provided because we have opened a little bit more this stack to be able to control through your own design, because you will have some specificities on some GPIO specific and so on due to your own hardware design. We provide a stack which is open enough to control all the stack and give you some access to different parameters you cannot have access when you run the Kinesis stack on the Nucleo board. For example, you can control the RF power level just to adapt this level to control an external PA, the frequency band, the modulation type, and the TCSO control, and also the MAC access to the Kinesis stack. Now, I think we have some questions, so we will try to answer to some of them. We have probably enough time to answer to all of your questions.
Okay, thank you, Steve.
Okay.
I have looked. I have looked at some of the questions, so I think we are ready to answer some of them. So some are for Kinesis, some are for ST. Anisette already started to answer a few questions on his side. So I will take a few questions for Kinesis. There was a question by Omar on which modulation we use. So the modulation is BPSK. Plus or minus 1.1 radian, so it's a special BPSK. There was a question from Florian. Can this STM32WL system on chip communicate with all the Kinesis satellites since it doesn't have QPSK modulations? So all satellites in orbit today and all future Kinesis satellites receive the BPSK modulation. So yes, this STM32WL will be able to transmit messages to all Kinesis satellites. Okay. Either with the very low data rate modulation at low power, so with the internal power amplifier integrated into the STM32WL, or adding an external power amplifier for the low data rate modulation with standard 19-byte messages. So 3-byte messages for very low data rate with the internal STM32WL power amplifier, or 19-byte standard messages with an external power amplifier. That's the message that that you should remember from this.
There is a oh. Yeah, there is a question about the two-way communication. So if you want to use bidirectional communication provided by Kineis, the STM32WL is not the right candidate. Anyway, you can use the bidirectional feature of the STM32WL for terrestrial communication, LoRa, Sigfox, and so on. And today, the WL is used in uplink only for Kineis. So we do not need to communicate with Kineis. We do not need the uplink, the downlink. There was another question concerning the security. So as I mentioned, the Kineis stack is using some external function which has to be implemented by the integrator. For example, all the credential management are managed by the integrator. So, for example, the Kineis stack use some keys, some AES computing, on some credential storage, and it is not integrated inside the stack. So that's why for US market, for example, because I saw a question, for the US market, it will be up to you to decide to use the cryptographic internal MCU of the STM32WL or not, because it is not integrated inside the Kineis stack. We just use a way to get access to this credential, and every manufacturer can manage it as he wants. So if he wants to be not to put it in a cryptographic MCU, he can do it, and he could address more easier the US market. I don't know if it answers your question, but just to be sure that you have understand a little bit why we are using PA, why you are sometimes we are using internal PA of the WL. Internal PA of the WL is able to reach 22 dBm, and it allows us with a secure budget link to address with low data rate modulation with 22 dBm, only 3 bytes payload for the customer. You have to increase the power level if you want to address the higher data rate modulation, but you need an external PA. What is the maximum transmission power? There is no specific maximum output power in this band. You can reach more than 30 dBm. But for an IoT device, it is better to reduce the power level. So for Kineis constellation, for sure, it is not necessary to transmit with more power than 27 dBm. Can receive from satellite, yeah, okay.
So we have a question on the satellite emulator.
Yeah.
Is operating with the satellite emulator locally unlimited and unrestricted in time, unlike the free evaluation program? So there are two different questions here. Operating with the satellite emulator locally could be restricted in time if using an antenna, because potentially the signal can reach the satellite. So we still there is a minimum transmission period to respect, which is 60 seconds. So you can transmit one message every 60 seconds. But it's not limited during the day, like the satellite passes would be, since you can communicate with the satellites only when the satellites are available. But this limitation does not apply to the satellite emulator, since you have the satellite emulator with you. And then it says, unlike the free evaluation program, so indeed the evaluation program is free, but it can also, the evaluation program can be used also with the satellites. But when using the Nucleo board, the STM32WL Nucleo board, as Steve said, you can address today with the internal PA inside the chip. You can only address one of our satellites that can receive these very low data rate signals with 3 bytes of data. So indeed, it reduces the availability in time for the satellite test, but it is available. I hope I answered the question.
There is a question about the frequencies worldwide. Yes, the same frequency is used worldwide, so around 400 megahertz. So there are 2 steps in this development for the WL. The first one is evaluation for free with the Nucleo board. And when you switch in a homemade design, chip on board design, you have to sign a contract with Kineis, and you will be supported to integrate our ref design. This ref design are accessible through this contract, and we support you till the end of this contract, which is the certification for Kineis. So certification is based on some measurement done on the radio modulation quality when you are doing your homemade design, because you are changing the PCB layout, T6 choice, and so on and so on. That's a satellite emulator as an open API. So the satellite emulator is, there is a graphical interface to control this satellite emulator, but there is also an access to a kind of API to be scripted and to be used with an external application through an API, and it is very easy to use and to script also.
I think we misunderstood the question from Stefano about the satellite emulator. He's completing the question by asking if the satellite emulator is limited to 3 months.
No.
As the free evaluation program. So the answer
is no. There is no limitation. This is a PC application which is used to control the SDR-based equipment, and you can use anytime you want. You just buy on the shelf this hardware equipment, and the software has no limitation. It just demodulates locally according to the different modulation you choose. You can play with it all the time. The only restriction with this kind of equipment is that you have to take care about the RF level, because it is very sensitive, or not really sensitive in terms of RF requirement. So you have to prefer to use a cable with an attenuator to use it. You can use the antenna which is provided with the Pluto equipment, but take care about some spurious which could destroy a little bit the signal and make the satellite emulator running not correctly. So that's it.
So the satellite emulator can be used with any Kineis device, any Kineis transceiver.
Exactly.
For tests. To simulate the uplink data reception by the satellite, and the downlink data transmission by the satellite and reception by the device.
Yes, so the satellite emulator is running in 2 ways, because you have on the Pluto equipment RX and TX RF output on an SMA connector, on the satellite emulator is able also to have the same behavior of the satellite to respond to a device.
So there's a question from Omar.
Yeah.
We can use other SDR or only this?
Okay, so to be completely transparent, this is based on IIO driver for some IIO driver which are available today for many platforms, Windows, Linux, and so on. The satellite emulator is running on Linux on the Windows. It is using the specifically this Pluto specificities with a dedicated sampling rate and so on. Can you use directly this software through another SDR-based equipment? It could be possible, but anyway, to be honest, probably some modification are needed to control another equipment due to the fact that probably you won't have the same sampling rate on the other SDR equipment like Etus or something like that. So this kind of equipment, Pluto, has not a big cost. It is less than $200. So you can buy it through Mouser or DGK. So you use it and you will see. But you can try to plug it with another SDR equipment, but not sure it will work correctly due to specificities of the sampling rate used in the Pluto.
So the answer for a guaranteed communication would be no. So before going on to the next question, I think we have one next slide that is very important because it presents the Kinesis knowledge base where a lot of questions can be answered. So before we leave you, we'll still answer a few more questions, but before we leave you, here's the link to the knowledge base, so connect.kinesis.com. You have the QR code that you can scan here, and that will redirect you directly to the article about the SmartSat program and how to start the SmartSat program. So on this knowledge base, there are a lot of information that are available publicly without logging in. And then there's a private access for partners under NDA upon login, where you will have access to all product documentation, including quick start guides and integration manuals. And you can learn more about the Kinesis system, the Kinesis performances, etc. And the article that the QR code redirects to, you will find what Steve presented, the step-by-step quick start to enter the SmartSat program. So how to buy a board from ST, what antenna to buy, and then the different steps, flashing the Kinesis signature on the board, and sending the signature code to Kinesis to have your full code, full Kinesis stack sent to you. So after presenting this knowledge base, I can answer a question from Jordi asking if there are any, if there is any small form factor antenna reference design provided. On the knowledge base, there is a section on antenna integration where you can find a few off-the-shelf references for antenna solutions that are suitable for Kinesis and that we tested, and a few reference designs as well. The antenna integration section is restricted, so please contact us if you want to have access to this knowledge base.
Someone is asking if we can have a quick demo on the on the Nucleo board, running probably with the satellite emulator. If we have, yes, we have 5 minutes left, we can do it. So in live, I will try. I just prepare. Perhaps you have some question to answer, waiting for my setup to be ready. Okay. So okay. Okay. So I could share my screen if you want, because it was okay. So I will start sharing. Okay. Share. Okay. 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 So you can see my screen probably now. We have the satellite emulator, which is running now. I have chosen the VLD-I4 modulation, and this modulation should be demodulated by the satellite emulator. And I am using the antenna. That's why we can find many signals, because we are at Kineis and many signals are on the air. Anyway, I will show you the KDI interface. You can see this interface. So you have two different modes for the KDI. One is periodic. Periodic, what does it mean? It means that the payload you can see here will be sent every minute. And if you want some repetition for each payload, it will be repeated 4 times, for example, every every 30 seconds. So if you play with the satellite emulator, it is a periodic transmission which is used, and you can use this one. And I will put this payload on start. Sorry, but I will. Okay, and when I click on start, okay. Sorry. The demo effect. Sorry. Okay, so we should have seen now the payload which is here. It's very strange. Okay. When I start the payload transmission, sorry, it's difficult to display.
So Steve, okay, yeah, I think Steve had some issues with his computer, but anyway, the session was planned for 1 hour. So thank you everyone for joining this webinar. As I wrote in the chat, the replay will be available, and the slides will be made available as well. So thank you everyone for joining, and we'll see you for the next webinar. Thank you so much.
Thank you.
Thank you.
Bye-bye.
Bye-bye.